Hello, Dr. Shaw and fellow classmates. My name is Luke Roberts, and today I will be talking about the Hubble Space Telescope. As you may have already learned from the textbook, Earth's atmosphere does not allow all wavelengths to reach the surface, and this makes it difficult for ground-based telescopes to observe the universe. The Hubble Space Telescope orbits the Earth 353 miles above the surface for this reason, and is flying around at 5 miles per second. This means that Hubble can go across the United States in 10 minutes. The Hubble weighs about 24,500 pounds and is 13.3 meters long. The Hubble is known as a Cassegrain reflector. This telescope works by allowing incoming light to reflect off the primary mirror, which has a diameter of 2.4 meters, and then redirects the light to a smaller secondary mirror. The light then bounces off the secondary mirror and is focused through a small hole and is captured by the instruments within the telescope. The Hubble has various instruments used for different measurements and wavelengths. The first of the instruments I will discuss is the Wide Field Camera 3, or WFC3. The WFC3 is one of the newer instruments and can collect ultraviolet, near-infrared, and visible light, and is being used to study dark matter. The two photos pictured here are of the Carina Nebula, imaged by the WFC3. The image on the left is the nebula using visible light, and the one on the right is the same image but using infrared instead. The Cosmic Origin Spectrograph, or COS, works exclusively with ultraviolet light and can measure temperature, composition, density, and motion of a given object, and improved Hubble's UV sensitivity by a factor of 10. The Space Telescope Imaging Spectrograph, or STIS, operates with ultraviolet, near-infrared, and visible light, and is known for hunting black holes. The STIS is no longer in operation, but when it was able to map out larger objects than the COS, such as galaxies. The Advanced Camera for Surveys, or ACS, increases the possibility for new discoveries by the Hubble by a factor of 10 and works with a broad spectrum at light ranging from ultraviolet to visible light and infrared. The ACS is used to observe a large area of the sky at once. The most famous image taken with ACS is pictured here and is known as the Hubble Ultra Deep Field. The near-infrared camera and multi-object spectrometer is sensitive to infrared light, which works as Hubble's heat sensor. This instrument allows Hubble to observe objects deep into space. The fine guidance sensors keep Hubble pointing in the correct direction by locking onto certain guide stars, and can also measure the distance and relative motion between stars. The James Webb Space Telescope is the next generation in space exploration and is sensitive to infrared light. This telescope is set to launch in 2018 and will observe how the first galaxies and stars formed, as well as searching for life in other planetary systems. As you can see by the picture, the telescope has a segmented primary mirror, which will expand after launch and is 6.5 meters wide. The JWST also orbits the Earth approximately 1.5 million kilometers above the surface. Here are a couple more photos from the Hubble Space Telescope. On the left is perhaps the most famous image taken by Hubble that shows stars forming in the Eagle Nebula. On the right is a series of recent images that Hubble has captured, showing the mysterious disintegration of an asteroid. This concludes my discussion on the Hubble Space Telescope.